Welcome back, and hope you have gone through the previous lecture. And this lecture, we are going to discuss something related to different libraries which is available in Python, especially for data science environment. So, as we are aware, Python is actually having got a good number of library collection in different domains, and we are going to discuss some of the basic libraries which is applicable in data science environment. So these are the libraries we are going to discuss. Something like the first one related to how to handle the arrays, etc. That is related to handling the one-dimensional, two-dimensional, or three-dimensional values that we call it as NumPy. And the second one, we are going to discuss something related to how to handle the data similar to our programming environment. For that, we are going to discuss something related to pandas. And the final one, which is actually for plotting the data, and for that we are using matplotlib. And in addition to matplotlib, we have got the cban, and that is also used for visualizing some kind of statistical information. So these are the main libraries we are going to discuss: NumPy, Pandas, Matplotlib, and Seaborn. The first one, NumPy. NumPy is actually considered as a kind of library for ensuring scientific computation, for supporting the scientific computation. By default, if you have gone through the previous lecture, you can see that there is no data structure related to keeping the data in a homogeneous way. Like what we have seen in the list and tuple or in dictionary, what we have seen is like it is always holding instead of holding homogeneous information, it is always keeping heterogeneous data. So when it comes to the data, especially for the scientific computation, we can see that heterogeneous or the so-called scientific computation always supported with the so-called homogeneous data. And for holding homogeneous data, the traditional programming always uses the concept of arrays. And traditionally in Python, this concept is not there. And to incorporate that particular concepts like multi-dimensional arrays, matrices, etc. in this particular for the scientific computation, Python having a library which we call it as NumPy. Then the second one, which is related to handling the data, that is something similar to the R programming language. One of the most powerful feature of R is actually it can handle the data, and after handling the data, it can process the data, and you can visualize the data. These are the major properties of R programming language. So similar to that, Python also having that capability. That capability is inherited by means of pandas library. Then for visualization, we have Matplotlib, and this will help you to visualize the data almost similar to MATLAB environment. Then an extension, like if you are really looking for statistical visualization, there is one more library which is known as Seaborn, and it is basically based on Matplotlib, and it has got almost all features related to the statistical graphics which is required for statistical domain. First one we'll discuss about NumPy. So the idea of introducing NumPy means how we can use this NumPy package for in our programming environment. So NumPy, as an introduction, NumPy is considered to be a fundamental package needed for scientific computation, and it is considered as one of the powerful n-dimensional array object, and it supports almost all basic linear algebra functions, and it has got also the capability to process Fourier transformation, and it has got the capability for generating the random numbers, and of course for the scientific computation, of course always we needed to have the integrations with other programming language like Fortran, and it is also supporting integrating with the C++ code. So the idea of in NumPy is purely driven from the scientific computation. In Python, in traditional approach, in Python, we don't have any homogeneous way of representing the data. All the data is considered to be heterogeneous, and it is not tightly coupled data. So to avoid that scenario, this particular library, NumPy package, will help you to introduce the concept of array, and that array we call it as a NumPy array, and that is represented as NT array. So it is actually n-dimensional array, which is a homogeneous collection of items indexed using n integers. So for this case, you can see that how you can define something like an n-dimensional array. So it supports one-dimensional, it supports two-dimensional, it supports three-dimensional, or it supports multi-dimensional. So that's why it is known as n-dimensional. But still, for our easy understanding, we are actually restricting ourselves within this particular three-dimensional domain. So if I am going for the one dimension, I'll be only using one element to represent this array. That is, I will be having only a traditional one-dimensional array. And if I would like to represent two-dimensional value, I'll be using x and y parameter so that I can place the data in a matrix or similar table format. So by this way, I'll be able to access the data by means of rows and columns. And if I'm looking for three dimension, I'll be giving one more data which is related to the third axis, Z axis. And this axis will help you to identify how many elements which is part of that Z axis. As an example, you can see here, like it is representing three-dimensional matrix and or three-dimensional array, and we can see that 4 representing the first value, how many rows it has got, and the 3 represents how many columns it has got, and the 2 value represents how many z-axis it has. That is, at this particular point, that is this xy point, it is maintaining two data, that is data 1 at this position and data 2 at this position. So that's why this idea is helpful. That is, it supports by putting multiple values. You can create multi-dimensional arrays, and it has got also having a property that if you are looking for defining a matrix or defining an array, and along with that you are trying to initialize an array, this NP array or NumPy having a capability that it will automatically initialize the positions with a given set of values, maybe zeros and ones. That type of initialization is permitted, and it doesn't need to have one more program to run to initialize the value. So we need to just place this kind of function called zeros, and that will replace or that will update all the position with zero value. Similarly, if you are looking for random values, and we have the random functionality, and random functionality will help you to initialize the value with a proper randomized set of values. So this is an example for the NT array data structure used in NumPy. So as we have seen, like how to represent multiple dimensional arrays in NumPy. So we can represent a one-dimensional array. That is one-dimensional array. I just will be placing the data in 1, 2, 3 format. That is a one-dimensional array. So if I am looking for two-dimensional array, you can look at the how we are placing the data. That is, you can see that there is something like two square brackets and outer square bracket representing it is a two-dimensional, and each element in that square bracket represents another way of representing the list and where you are placing the data. So you can see that this one representing the first row, this value representing the second row, and this value representing the third row. Then if you are looking for defining the three-dimensional values, you can see that how it can be realized by putting two outer opening square bracket, and after that you will be putting a kind of a row information. Then by this way you will be putting all those information. That indicates that this can be represented as a kind of a three-dimensional element, and that is realized with simple coding statement. And it also following the similar way of accessing the data which we have seen in other programming languages. It's actually keeping the data as a block, and if you want to access the data like the first element, second element, third element in one dimensional array, if it is two dimensional array, row and columns value will be specified, and using that column and row value you'll be able to extract the information. And if it is three dimensional array, you can easily access the data by representing x, y, z values. So as an example, here we are using some example statements like we have got a equal to array 1, 2, 3, and this is being initialized, or you can visualize it something like this one. So if you are putting a something like a dot shape and a dot d type, it will give you different answers. Let's see what is going to happen with shape. Shape is giving you the overall structure of the array which has initialized, and a d dot type representing or giving us the data type which is holding the data. Then the indexing positions, like indexing positions are almost similar to the traditional metrics, like by putting the row column values, we'll be able to access the two-dimensional value. By putting x, y, z value, we'll be able to access three-dimensional value. By putting a single element, maybe x, and you can access a one-dimensional value. And similar to list and tuple, which we have seen, NP arrays or the NT arrays or the NumPy arrays also supporting slicing. And slicing, as we have seen, that you can select or you can extract some of the information from existing list or tuple. Similarly, if I am having an array, I will be able to extract some of the information, and that is actually the idea of slicing. So different approaches are mentioned here, how we can extract the data, and highlighted value represent the outcome of that execution. So for this case, for we have got a 4 into 4, 4 into 3 matrix, and I just want to perform some of the slicing statements and look at the way how we are placed all the slicing statements. So array 1 colon without any ending colon, you are closing that particular, you're putting the closing square bracket. It indicates that it will eliminate, or it will try to keep all the data from uh, the second row onwards. That is, 0 represents this row, 0 represents this row, first row, 1 represents second row, and 2 represents third row. That is, always our indexing starts from 0. That's why we are putting, or we are using that logic. So if I have placed 0, that will be showing the entire matrix, but here, since I have placed 1, it indicates that it will be starting from the first row and showing the all the elements. So it will extract all the elements from first row. It won't consider the 0th row it has. Then if I consider array without any parameter, I am putting a colon and then putting a 0 represents, it will generate a subset of this given array, and since it has mentioned as 0, it will only extract the 0th position column, and you can see that 159 will be extracted. Similarly, if you are looking for a subset of the column, that is it is actually taking the value like 1 1, that is from this point it is tracking the data, and -1 indicating that it will remove all the so-called outer elements, and it will take only the inner elements from within this particular array. So similarly, you can see different examples here. All these examples are some way of extracting the information or slicing the information from given array. So the next one, we are going to discuss something related to some of the methods which is part of NumPy. So if you have declared an array in NumPy version, and there are a set of built-in functions. That built-in functions will help you to perform the actions even without writing a kind of number of statements there. The first one, if I'm having a array and I just want to convert that array into a list, I can simply convert it into a list, that is by putting to list. So we know the properties of a list. A property of a list means it is never going to be a kind of a it is never going, we don't have any kind of a strict rule for the list. Like a strict is list is supposed to be following the heterogeneous way of keeping the data. So that is actually, if you are looking for something like a conversion in between, you can directly try to list operation. Then you can try a function called array copy, that will copy an array to a new array. Then if you are looking for filling that with a set of scalar values, you can try that one in array. That is right now we have already seen that you can fill it with zeros and ones. Similarly, if you are looking for fill the value with a particular scalar element, you can try it with this particular function array dot fill. Then we have got some other NumPy functions also. The first one is ABS. Then we have the add. We have got the functionality to perform binomial. Then we have the function for floor, minimum, maximum, multiply, shuffle, transpose. So all these functions will help you to perform a number of actions or execution or computation statements related to the statistical computation approaches. So that is actually the most powerful part of NumPy. If you are looking for multiplying something like two arrays, it is very easy in Python. Like you don't need to call the so-called you don't need to implement the traditional matrix multiplication approach. Instead, you can make use of the built-in functions and you can perform the multiplication.